Dear students, welcome to virtual classroom of Municipal Corporation of Greater Mumbai. I am Sreekumar. The class is for 9th standard students. Subject is mathematics. Let me begin the class.
Now let us try to understand a different scenario to understand the relation among trigonometric ratios. The trigonometric ratios are the ratios like sine, cos and tan. Just now we understood. For sine it is talking about sine of a particular angle in the right angle triangle is opposite side of one hypotenuse. Cos is adjacent side of upon hypotenuse. Tan will be talking about that angles opposite side upon adjacent side. Let us understand this in a different way. Here is a triangle in front of you, very simple triangle, and it is a right angled triangle. Let me name this triangle as P and M, and this is the right angle, right? This is the right angle. If this is right angle and if I name this angle as theta, a measure, any measure it can be, this will be, this is 90 degree, this is theta. We know that in a triangle the sum of the three angle is equal to 180 degree. Naturally, if you subtract this one, it will become 180 minus 90, which is equal to 90 degree will be the sum of this angle and this angle. Of that theta is this angle, means this will be 90 minus theta. So we understood if this particular angle is 90 degree and this is having a measure theta degree, naturally this angle P angle will be equal to 90 minus theta. Okay, this much you should keep clearly in your mind. By keeping this in mind, we are trying to apply the learned ratio, that means sine of a particular angle, sine theta, cos theta and tan theta in this particular triangle. Then we will be writing sine theta as, that means sine ratio of the angle having measure theta, which is equal to, this is the opposite side of it and this is the adjacent side, right, as far as this angle is concerned. So we will simply write Pm upon Pn as the ratio, correct? Then if we are writing cos theta, which will be talking about adjacent side upon hypotenuse, adjacent side is Nm here and hypotenuse is Pn, the same. Okay, tan theta will be tangent theta, tangent ratio of the angle theta will be equal to the opposite side upon adjacent side, and opposite side is Pm and adjacent side is Nm. There is no doubt about it. When considering this angle, if you consider the sine of 90 minus theta angle, this angle, what is opposite here? The opposite side is Nm upon the hypotenuse is same, because it is opposite of right angle, naturally it will be Pn. Then cos of the angle 90 minus theta, you will be writing it as Pm, the adjacent side, this became the adjacent side, upon the hypotenuse. Then tan of 90 minus theta will be written as naturally Nm, which is opposite side, and adjacent side, which is Pm. You can see a relationship here. This is Pm upon Pn, correct? Pm upon Pn. This Pm upon Pn became equal to this cos 90 minus theta. Cos theta, which we are having Nm minus Pn, became sin 90 minus theta. Understood? So there is a relationship between sin theta, this angle, this particular angle, the ratio of opposite side and hypotenuse, and this particular angle, its opposite side and hypotenuse. The sin theta will become cos 90 minus theta, cos theta became sin 90 minus theta, tan theta and tan 90 minus theta are inverses, Pm upon Nm, Nm upon Pm. This kind of ratio, but from one ratio we are reaching to another ratio. Understood? So we understood this relationship. We can simply rewrite in such a way that sine theta is equal to cos 90 minus theta in this case, correct? And cos theta is equal to sine 90 minus theta. This also we observed. And as these are opposite, if we simply write tan theta into tan 90 minus theta, so what will happen? It will be multiplying Pm upon Nm into Nm upon Pm, and the answer will become 1. On the other hand, if you think about for a fun, I mean, sine theta upon cos theta, if you are multiplying here, we can just simply do this exercise of writing one upon the other. So what we will write, sine theta is this Pm upon Pn, correct, divided by cos theta, right? You will write Nm upon Pn, that means we have to multiply, it will go opposite, we will write Pm upon Pn, one second, into the other one opposite, inverse of it, Pn upon Nm, opposite, inverse of it, and we will see that this will get cancelled. Naturally it will become Pm upon Nm. What is that? Which is tan theta. तो क्या समझ में आया हमको ये रिलेशनशिप देख के वंडर हो रहे. व्हाट इज वंडर? साइन थीटा, कॉस थीटा, tan theta, there is a simple relationship between the opposite side and hypotenuse, adjacent side and hypotenuse, and the relationship between opposite side and adjacent side. But when we took the other angle, which is 90 minus theta, for symbolically, we found that sin theta is equal to cos 90 minus theta, connect हो गया, cos theta is equal to sin 90 minus theta, that means let it be any other angle, then tan theta having an inverse proportion, and tan theta and tan 90 minus theta of other two sides, we will get 1, and if it is sin theta upon cos theta, it is equal to tan theta. So a lot of beautiful relationships are developed. Otherwise also Pythagoras also talked about relationship. 30, 60, 90 degree theorems also talked about relationship between the sides of the triangle. 45 degree, 90 degree triangle theorem also expressed the relationship between the sides of the triangle. Here this also, trigonometry is also talking about the relations among the ratios of the sides of the triangle. So my dear student, things are getting interesting. This is from your textbook. Cos 90 minus theta is equal to sin theta. Sin 90 minus theta is equal to cos theta. Sin theta upon cos theta is always equal to tan theta. And this theta is our angles. आप तो angle डालेंगे. Theta एक alphabet use किया in Greek. Tan theta into tan 90 minus theta is equal to 1. Please remember this relationship very clearly so that it will be easy and interesting for you to learn further in trigonometry. Okay, we'll go ahead. You can pause here, think about what I said. You can review this. Beginning of this lesson, I told you about you should remember about Pythagoras theorem. Then I told about similarity of triangles. Also told that you should remember about 30, 60, 90 degree theorem. I think you remember that what I told. Why? Because trigonometry deals with this peculiar triangle. What is that 30, 60, 90 degree triangle made us understand? It made us understand that, let me draw a triangle. Yes, I can make it 30, 60 by adjusting a little. Okay, this is a 30, 60, 90 degree triangle. And if I name the triangle as, for example, A, B, C, and as I showed you, this is 60 degree, this is 90 degree, and this is 30 degree. You should go to the lesson triangle and recollect everything, because I am not going to tell everything, just I will say the matter. In such a triangle, we studied that side opposite to 30 degree, that is this side AB. The measure of AB is half of the hypotenuse, that is that of AC. This is what we concluded in the chapter. Also, the side opposite to 60 degree, that is this side, which is named as BC here, that is BC is equal to root 3 upon 2 of hypotenuse. This is what you studied there. Now, just now we studied that if you consider those trigonometric ratios here. What were they? The trigonometric ratios connected with the right angle, the triangle, where we found that how these trigonometric ratios can be applied in 30 degree and 60 degree triangle. We will see that now. Suppose that if I write this triangle in such a way that we have a triangle, and if I simply write this side is equal to A. So naturally A is opposite of 30 degree. Opposite of 30 degree is half of AC. Correct? That means AC is equal to twice of AB. I just wrote AB is equal to A. The side AB is equal to A. Then side AB is half of AC. That means AC is twice of AB. So this will become 2A. Correct? If you write in terms of A, this will become 2A. And side opposite to 60 degree is root 3 upon 2 of AC. We got AC now. So root 3 upon 2 of AC, which is 2A now, we will cancel this. So naturally this will become root 3A. We applied that theorem of 30, 60, 90 degree in terms of sides now. We are slowly going close to trigonometry. If this is true, we just found that in the case of trigonometric ratios, what the ratio is telling? The ratio of, in this case, sine of angle 30, sine ratio of angle 30, you can cancel E, sine of angle 30 is nothing but, in this case, opposite side, which is AB, upon hypotenuse AC. What is opposite side? A. What is the hypotenuse? 2A. The result is 1 upon 2. Think about cos 30. What will you say? Adjacent side upon hypotenuse. What is adjacent side here as far as 30 is concerned? Root 3A upon hypotenuse 2A. Again cancel this. You will get root 3 upon 2. What is tan 30? Tan 30 is opposite side upon adjacent side. Opposite side is A here, this one. Adjacent side is root 3A. A will get cancelled, you will get 1 upon root 3, the value of tan 30. The same way, if I write sine 60, this is 60. Opposite side is root 3A upon hypotenuse 2A. A get cancelled, we get root 3 upon 2. Cos 60, what will happen? Opposite side of, adjacent side of 60 is A upon hypotenuse 2A. We will get it cancelled, 1 upon 2. Tan 60, opposite side is root 3 upon A, adjacent side is A get cancelled, which is equal to root 3. We got in a 30, 60, 90 degree triangle, the trigonometric ratios, sine 30 is equal to half, cos 30 is equal to root 3 upon 2, sine 60 is equal to root 3 upon 2, tan 30 is equal to 1 upon root 3, tan 60 is equal to root 3. We got all these answers. Understood? And this is applicable to 30, 60, 90 degree triangle. This trigonometry will be helping us to fix the ratios or the size of the sides of a right angled triangle. Understood? Just remember that sine 30 is equal to half cos 30 is equal to root 3 upon 2, tan 30 is equal to 1 upon root 3, sin 60 is equal to root 3 upon 2, cos 60 is having a value 1 upon 2 and tan 30 is having a value root 3. Let us apply the same principle in the case of a triangle 45, 45, 90 degree triangle that also you studied in the triangle chapter. A 45 degree angled triangle, that is 45, 45, 90 degree. How it would be? Let me make a triangle. It should be 45, 45, 45. There you go. Now it is 45, 45 degree triangle. Let me name this triangle as A, B, C. Angles are 45 degree, 45 degree and 90 degree. Okay. This is a right angle triangle and Pythagoras theorem is very much applicable to this. If I write AB as A, size of AB as A, this also will be A because it is an isosceles triangle also. Isosceles triangles are those triangles, two sides are congruent. Then only this 45, 45 degree will match here. If these two are A and A, according to Pythagoras theorem, AC square is equal to AB square plus BC square, where AC square is equal to AB square is A square plus A square. That means 2A square. AC is equal to root of 2A square. That means root 2 का स्क्वायर नहीं मिलेगा, A square का स्क्वायर रूट A हो गया. Answer is root 2A. That is the value of hypotenuse. Now suppose if you apply our knowledge of trigonometric ratios in this case, 45 degree and this is also 45 degree. There it was 30, 60, this is both are same, so you will have same answer. Think about sine 45 degree, angle 45 degree, opposite of sine 45, this one, and hypotenuse is this one. That means A upon root 2A gets cancelled and you get the answer 1 upon root 2. Cos 45 degree, opposite of cos, adjacent for 45 degree, again it is also A. Adjacent and opposite are A here. Hypotenuse root 2A. Answer is 1 upon root 2. That means sine 45 and cos 45 degree are having same answer. Tan 45, interestingly, it will become A upon A, which is equal to 1. So you got a new ratio now. The ratio in such a way that ratios are in such a way that you have sine 45 is equal to 1 upon root 2, cos 45 equal to 1 upon root 2, tan 45 is equal to 1. Suppose if you try to make a trigonometric ratio for, make it variable. We are trying to find out how to find out sine 0 degree. For that we need an angle 0 degree. To have an angle 0 degree, look at this triangle which I will be drawing very specially. This is a triangle. Let the triangle be, I will show you, this triangle be ABC, like this, A, B and C. This is 30 degrees suppose. If I bring down to this to 0 degree, then sine 0 degree you can find out. To bring down 0 degree, I should reduce this height. So I am going to do that with another triangle. My limitation with this triangle. So see, now it is, here it is 2.5 centimeter. I am bringing down the height of it. 1.3 centimeter, 0.6 centimeter, 0.4 centimeter, 0.3 centimeter, 0.1 centimeter, 0 centimeter. That means here it became, that means here it became 0 degree. That is AC is equal to 0, this 0 degree is 0 centimeter, not degree, 0 centimeter. Here AC was having 3 centimeter or something, here it is 0 centimeter. And here it became 0 degree, angle B became 0 degree. So we got 0 degree here, 0 centimeter here. Now let us think about sine of 30. We will write AC upon AB, correct? This one. Now here it is sine 0 degree. Sine 0 degree, AC has become 0. And AC has become 0. AB is the hypotenuse. This one, it is as it is. But if you divide any number with, if you divide 0 with any number, your answer will be 0. So sine 0 degree is equal to 0 degree. Understood? Sine 0 degree is equal to 0 degree. That is one thing. Now let us try to find out sine 90 degree. We have a trial now. Give me a second. We are formulating sine 90 degree. How to get sine 90 degree? Opposite upon hypotenuse. Hypotenuse is always opposite of 90 degree. So we will come from another angle and try to make that angle 90 degree. For example, here I am going to draw a triangle like before. Here is a triangle. This triangle is having measurement and name like this, A, B, C, and this is 30 degree and this is 90 degree, suppose. If I can convert this into 90 degree, then I can get sine 90 degree because this will become opposite side and this will become hypotenuse. Right? Here is a triangle where this angle, where my mouse is, 44 degree now, 48 degree now, 63, 70, 87, 88. As soon as I make it 90, the angle disappears. So it is at 89 I stopped in order to show you. If I move further, it will become wrong. It will not be a triangle. But 89 will become 90 in the next move. Suppose this triangle, suppose that this triangle, by changing this 30 degree into 90 degree, became like this. The name of the triangle will be again A, C, B, and if I substitute sine 90, I have to calculate sine 90. What is a sine 30 in this case is AC upon AB. Sine 90 here, the 30 converted into 90 here, that also will become AC upon AB. But AC is equal to, this is AC, right? Here it is AC. AC has become equal to AB. I will show you once again. See, when I bring it down, AC is coming close to AB and it becomes 1. So AC became equal to AB. Understood? So, if both are same, answer is 1. So, sine 90 degree is equal to 1. One more information for you. So, you learned a lot of relationship. Here, just now you learned sine 0 degree is equal to 0, sine 90 is equal 90 degree is equal to 1. So, in that case, cos 0 degree also will be, if calculator will be 1, and cos 90 degree is equal to 0. Ulta hai. Cos 0 degree is equal to 1 and cos 90 degree is equal to 0. All these relationship you can get like this. Now, what basically you should understand, that trigonometry is telling about the ratios of different sides of the triangle in different situations. Situation means when the angles are changing. So we will make a chart of this so that it will be easy for us to remember and understand. The chart I will be showing you just now. Here comes the table summary of whatever trigonometric ratios you just learned. You learned about the trigonometric ratios of different angle, 0 degree, 30 degree, 45 degree, 60 degree and 90 degree just now in the video. Here is a summary of it, or a table to remember. You can do either you can construct this yourself in your mind and remember it. Sine 0 is equal to degree is equal to 0. Sine of 30 degree angle is equal to, the value is 1 upon 2, and cos of a angle 45 degree, matlab cosine ratio of 45 degree angle is equal to 1 upon root 2. This is fixed. And the tan of a 60 degree angle is root 3. You understood this, or you found this is true in the video. Now you believe it. Now only thing left is you should remember it. Either you can by heart it and remember, because you understood there is no harm. Because when you learned 3 2s are 6, you first found that 3 2s are making 6. 2 plus 2 plus 2 is making 6. Then you by hearted it as 3 2s are 6. There is no harm in that. But without understanding, by hearting is a wrong thing. It won't help you. But here you have understood in the video that how these different values, each and every value we derived in the video. That means you are confident and clear about it. You can by heart it and apply it whenever it comes. There is an exercise, just following this, start doing it. As I always say, exercise is given for making yourself strong enough, whether it is physical exercise or mental exercise. This is mental exercise. Do the problem set number which is coming as problem set number 8, as well as the practice of 8.2 yourself in such a way that, my dear student, you will become strong in trigonometry. Why? Because there is a chapter trigonometry in the coming year, and the chapter is trigonometry. फिर उधर क्या पढ़ेंगे? Something based on this. Something based on this. So base should be perfect. Do it. Thank you. Now click on the subscription button below to subscribe the channel, then the bell button to get the notifications of the new videos. Thank you.